Special Relativity Theory. A critical review of attempts to justify the contradictory results. Part 2. Einstein's contradictory statements in relation to the constancy of the light's speed in vacuum. As reference, I've used the following German publication of Einstein from 1916. English translation of the book is also available on the internet. The first part of this booklet consists of 17 chapters as follows. Part 1. The Special Theory of Relativity. 1. Physical meaning of geometrical propositions. 2. The system of company ordinates. Page 5, 3. Space and time and classical mechanics. Page 9, 4. The Galilean system of company ordinates. Page 12, 5. The principle of relativity, in the restricted sense. Page 14. 6. The theorem of the addition of velocities employed in classical mechanics. Page 19. 7. The apparent incompatibility of the law of propagation of light with the principle of relativity. Page 21. 8. On the idea of time and physics. Page 25. 9. The relativity of simultaneity. Page 30. 10. On the relativity of the conception of distance. Page 34. 11. The Lorentz transformation. Page 36. 12. The behavior of measuring rods and clocks in motion. Page 42. 13. Theorem of the addition of velocities. The experiment of Fizeau. Page 45. 14. The heuristic value of the theory of relativity. Page 50. 15. General results of the theory. Page 52. 16. Experience and the special theory of relativity. Page 58. 17. Minkowski's four-dimensional space. Page 65. Einstein begins by elaborating on non-controversial simple physical concepts and paves the way to introduce his new ideas without providing a solid scientific argument about controversial issues, which could be the root of different interpretations on special theory of relativity. Here I have shown some conflicting statements in Einstein's own writing. In Chapter 7 of his book, The Apparent Incompatibility of the Law of Propagation of Light with the Principle of Relativity, he writes, the epoch-making theoretical investigations of H. A. Lorentz on the electrodynamical and optical phenomena connected with moving bodies show that experience in this domain leads conclusively to a theory of electromagnetic phenomena, of which the law of the constancy of the velocity of light in vacuo is a necessary consequence. But in Chapter 9, The Relativity of Simultaneity, he writes, up to now our considerations have been referred to a particular body of reference, which we have styled a railway embankment. We suppose a very long train traveling along the rails with the constant velocity v, and in the direction indicated in the following figure. People traveling in this train will with advantage use the train as a rigid reference body coordinate system. They regard all events in reference to the train. Then, every event which takes place along the line also takes place at a particular point of the train. Also, the definition of simultaneity can be given relative to the train in exactly the same way as with respect to the embankment. As a natural consequence, however, the following question arises. Are two events, for example, the two strokes of lightning A and B, which are simultaneous with reference to the railway embankment, also simultaneous relatively to the train? We shall show directly that the answer must be in the negative. When we say that the lightning strokes A and B are simultaneous with respect to the embankment, we mean the rays of light emitted at the places A and B, where the lightning occurs, meet each other at the midpoint M of the length A, B of the embankment. But the events A and B also correspond to positions A and B on the train. Let M be the midpoint of the distance AB on the traveling train. Just when the flashes of lightning occur, this point M naturally coincides with the point M, but it moves towards the right in the diagram with the velocity v of the train. If an observer sitting in the position M in the train did not possess this velocity, then he would remain permanently at M, and the light rays emitted by the flashes of lightning A and B would reach him simultaneously, i.e. they would meet just where he is situated. Einstein continues, now in reality considered with reference to the railway embankment, he is hastening towards the beam of light coming from B, whilst he is riding on ahead of the beam of light coming from A. Hence the observer will see the beam of light emitted from B earlier than he will see that emitted from A. This statement is a clear testimony against the postulate of the constant speed of light. Were the light speed constant and not dependent of relative velocity v, the observer and train had to see the both light beams simultaneously too.